set of numbers in a particular order or pattern. So we are going to be looking at lists of numbers, patterns in this unit. So for example, I might have 5, 7, 9, 11, 13. Do those follow a pattern? What pattern? Going up, adding by 2 every time. Very good. And sequences can be kind of divided into 2 categories, finite and infinite. You know what the word infinite means, right? So finite is the opposite of that. A finite sequence contains a limited number of terms. Like I have these 5 terms and that's all. I just have like my list of numbers there's 5 numbers in it, and every number we call a term. So when I say it has 5 terms, it has 5 numbers in the pattern. An infinite sequence is a sequence that never ends. If I wanted to say that this sequence goes on forever, what could I do to make that, to show that? Dot, dot, dot. Yes. Question?
Is this, are we going to have to like find the equation that makes that sequence work?
Yep.
Okay.
Not today, but we will. So when you see dot, 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 that's going to mean it's an infinite sequence. Here's where you might be thrown a trick question. Let's see. So this is not an infinite sequence. Even though it has dot, 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 it ends at 29. The dot, dot, dot just means this pattern continues until I hit 29. But it stops at 29. So you really have to look, where is that dot, dot, dot located? Is it at the very end, or is it sandwiched between some terms? If it's sandwiched between, it's still a limited sequence. It's still finite. Okay. You may see a question that says, is this an infinite or finite sequence? That's really the only time that you need to know the difference. That's not a huge part of this unit. The notation that we use is going to be a little different than what you're used to. So when we're talking about the first term in a sequence, and my sequence is up there, what is the first term? 5. When I'm talking about the first term, I'm going to use this notation. A lowercase a with a little 1. Whenever you see a lowercase a with something, that means one of the terms. So A1, instead of me actually just writing out first term, I'm just going to say A1. A1 means term 1. A7 means term 7. A50 means the 50th number in your list. So in general, when I say AN, I'm just meaning some number in the list. AN is just a general way of saying one of my terms. And N is just, it's the term number. So again, A7 is term number 7. A9 is term number 9, the 9th number in the list. And you will You will see that notation a lot. AN equals AN, AN. So here's a list of numbers. What is A1? 1. What is A4? 13. What about A10? What I would do is I would just keep writing out some numbers. What's my pattern? Up by 4. So 21, 25, 29, 33, 37. Let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My 10th number, my A10, is 37. Should be 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 37. So here are 3 sequences and they are misnumbered. This should say number 3. So with your partner, some of you it's the person beside of you, some of you it's only going to be the person across from you. Group of 3, you all can together. I want you to see if you can find the next 3 terms and then check with your partner to see if they got the same answer as you. So number 1, what was the pattern? Doubling, multiplying by 2. So it would be negative 32, negative 64, negative 128. That one was pretty easy to see. Number 3 should also be pretty easy. What's happening there? Add 5. I'm talking about number 3. I skipped to number 3. So this one you're adding 5. So that one was pretty easy. So 56, 61, 66. The one in the middle, that one was the tougher one. So this one, you're going up by 3, up by 5, up by 7. So the number that you're adding is increasing by 2 every time. So 3, 5, 7, 9. So I need to add 11, which would be 38, plus 13, 51, plus 15, 66. Most of this unit is going to be using what we call an explicit formula. And an explicit formula, or just a formula, sometimes we call that a rule. That's going to allow us to find any term of a sequence. For today, I'm giving you the formula. Later on, you're going to be coming up with the formula yourself. So basically, if you have a pattern, you can write a formula, and if I said, what is the 100th term in the sequence, you would be able to find that without having to add 2 plus 2 plus 2 plus 2 plus 2 over and over and over again. The formula would give you that. So here, I have the formula. AN equals 7 times n plus 3. This means that any term in my sequence I want to find, I'm using AN, I'm going to plug into this formula. So when I'm asking you to find A3, I'm asking you to find the 3rd term. So you're going to be plugging in a 3 for n. So the 3rd term. So A3 is 7 times 3 plus 3, which is really 7 times 6. which is what? 42. Good. Number 5, an equals 2 to the exponent of n plus 1. So if I'm asking you to find a1, you're going to put a 1 in for n. So a1 is 2 to the 1 plus 1 power. Which is 2 to the second power, which is really what? 4. Try number 6 when you get it done. All right, number 6, we're finding a7. So we have negative 4 times 7 squared. I'm going to bet a lot of you made a mistake. That is very common. And you did negative 4 times 7 and got negative 28, and then you squared that. You have to think order of operations. The squared is only being applied to the 7. So you only square the 7. So it's negative 4 times 49, which would give us negative 196. Questions? Okay. Then the last 3, I'm giving you a formula. I'm saying an equals 20. What that means is that 20 is one of the numbers in my list. What I don't know is how far down the list it is. That's what I'm asking you to find. When I say find n, I'm asking you to find, is it the 5th number, the 6th number, the 9th number, the 30th number? And so if we know that an equals 20, we're going to do some substitution here. We're going to take the 20 and put it in the spot of an. So we're going to do 20 equals 2n plus 4. So I'm not asking you to find the 20th term. We're not plugging in 20. I'm telling you 20 is one of the terms. Which term is it? So this would be 16 equals 2n. So 8 equals n. So what that is telling me is that A8, or the 8th term, is 20. So A8, the 8th term, is a 20. Try 8 and 9 and then check with your partner. So number 8, we should have set 45 equal to 5 times n minus 3. The easier option would be to divide by 5 first. You can do that. You can divide both sides by 5 and you would get 9 equals n minus 3, and then add 3 to both sides. Most of you, or a lot of people, probably would distribute first, which is not wrong. It just added more work. But you got your n is 12. This really only asks for n, which is 12. You don't necessarily have to write this out every time. I just wanted to point that out. And then 26 equals n squared plus 1. So you should have subtracted 1 to get 25 equals n squared. How do I get n?
Square root.
Square root. And what is the square root of 25? 5. So my 5th term is a 26.